All right, this is part 2 of the Algebra 2 video for section 2.2. We're looking at some examples. Again, this paper is something that you can print from the Algebra 2 documents folder. Okay, so we're going to start with the slope formula. Just to remind you, these two things right here have to be from the same point. So it could be the negative 2, 7, or it could be the 8, negative 6. I'm going to use the 8, negative 6, but it doesn't matter. And then these two things right here should be also from the same point, which would be the other point. So we already got some of it filled in, so we're going to fill in what's missing. So you can see that this negative 6 here is a y, and they're calling this y2 because they're putting it here first, which means y1 is 7, and that's what's going to be over here. So this is x2, which means that this has to be 8. And this was x1. It's already plugged in at negative 2. So substitute negative 2, 7 for x1, y1, and 8, negative 6 for x2, y2. We do a little subtraction. We get negative 13. Negatives will cancel like that, and that's 10. So that's negative 13 over 10. Okay, moving over to this one right here. Let's zoom in just a little bit. So we're writing an equation giving the slope and a point. So we're going to be using the point-slope equation, which was this right here. What we need is a point and a slope, hence the name point-slope. So the point that they give us is negative 1, 5. This is your x1, y1. It's any point on the line. And the slope that they give us is 3. That's your m. So I'm going to plug in the m with 3 and the x1, y1. So x1 goes here. You can see it's already in there. And y1 goes here. So that's going to be 5. So we substituted 3 for m and 5 for y1 and negative 1 for x1. So the x minus a negative 1 thing turns into a plus 1. And then we're going to use the distributive property to distribute the 3 here, and we get 3x plus 3. Now, you have to be paying attention to what they want, what form they want your answer in. So they said write in standard form. So standard form is the ax plus by equals c. So you have to get the x term and the y term on the same side in this order, and then any number you have is going to be over there. So to get this into that form, it's actually kind of a couple of steps. They didn't quite show it, so I'm going to show it over here. So we have y minus 5 is equal to 3x plus 3. Okay, so what they actually did was they subtracted 3 from both sides to get the numbers together. So we get y minus 8 equals 3x. Then they subtracted y, and we end up with negative 8 equals 3x minus y. But the 3x minus y and the negative 8 are on different sides, which of course doesn't matter. But that's what's going to go in that box, a negative 8. There's other ways that you can do that, but I think that's the easiest way to explain that. Okay, so now we're going to be writing an equation given 2 points. So the other one we had a point and a slope. This one we're given 2 points. Now they do it a little weird. What they do is they're using the point slope equation, but then where m is, they plug in the slope formula, which is really kind of a cumbersome way to do it if you ask me. But just so you know, all of this right here is the slope formula. What I would do is I would just find the slope using the slope formula and then plug it in. I don't like plugging a bunch of weird numbers in for one number and then figuring it out while I'm doing the other part of the process. So I'm going to go ahead and just do it on the side here. So y2 minus y1 over x2 minus x1. Again, it really doesn't matter which one you call which. Okay. I think that for this one specifically, they used x1, y1, x2, y2. But then down here that says you can also use 5, negative 1 as x1, y1 and 4, negative 3 for x2, y2, right? It doesn't matter. Okay, but I'm just going to go with this. So we're going to do y2, negative 1, minus y1, negative 3. So those are the y's. And then negative 1 goes with 5, so he's underneath. Minus 4, negative, negative. Negative 1 plus 3 is 2. 5 minus 4 is 1. We have a nice, beautiful slope of 2. So all of this, I already did that, and we get 2. That's our slope, okay? So I'll just put a little arrow over there. There. Okay. Don't disappear. All right, so then we have to plug in a point. Now, when you have 2 points like this, you get to choose. They're kind of sticking with x1 and y1 from their first labeling of x1, y1. So 4, negative 3 is what they chose, but you could use 5, negative 1. And if you get 5, negative 1, you will get a different answer, but it's equivalent. Okay, so they did 5, negative 1. See the 5 and the negative, negative 1 turned into a positive 1 there? You get this answer. If we plug in 4 and negative 3, you're going to have a 4 there and a 3 here because it'll be a negative 3, which will cancel. So this answer and this answer are equivalent, and you can tell that they're equivalent if you were to put them into slope-intercept form. You'd get the exact same thing. Okay, let's look at this one over here, finding slope using slope-intercept form. So this is in, what kind of form is that? If you said standard, you would be correct. Ding, ding, ding. It's the ax plus by is equal to c. Now, standard form has its purposes, but to graph something, it's not going to be so easy to graph it in this form. We like slope-intercept form because it's easy to graph in. Recall, slope-intercept form is y equals mx plus b. So in order to get from this to this, we need to isolate the y here. We want to get y alone. So the first thing we want to do is just move this term over. So it's negative, so we're going to add 7x to both sides. So if you add 7x, let me erase some of this. If you add 7x, this 7x will cancel. You get 2y is equal to 7x plus 8. Notice I put the 7x in front of the 8, not 8 plus 7x, because that's how slope-intercept form looks. Then we need to divide everything by 2, and we get y equals 7/2 x plus 4, because 8 divided by 2 gives you 4. So now we can identify the slope, which is m, which is 7/2. All right, last question. So it says writing an equation of a perpendicular line. Write an equation of the line through 5, negative 3 and perpendicular to 4x plus 1. Okay, let's start by talking about what we're talking about. There's a line, 4x plus 1. Let's practice graphing it. We're going to have to graph it anyway. So we begin with the b. The y-intercept is 1. Put a dot. The slope is 4 over 1. So 4 over 1. If we think of it as positive, positive, we can go up right. Or if we think of it as a negative over a negative, they would cancel. That's down left. Both of those will give you a positive slope. I'm going to go with up right. Up 1, 2, 3, 4 over 1. Okay, or I can go down 4, 2, 3, 4, left 1. Okay, there is our line, y equals 4x plus 1. So the question says write an equation of a line through 5, negative 3. So let's find the point 5, negative 3. So 5, negative 3. It's right here. All right, we want a line that goes through this point and is perpendicular to this blue line here. So the first thing we need to do is find the negative reciprocal of 4. Now, when I went over perpendicular, I said opposite reciprocal. Opposite negative works out the same way. So our slope here was 4 over 1. So we're going to take the reciprocal of it. That's 1/4. Put a negative in front of it since this was positive. So that's the slope that I'm going to use for m, negative 1/4. So this is a different way of finding a y-intercept. We're not using the point slope form. We're using slope-intercept form. So what you do is you take this point, 5, negative 3, and you're going to substitute 5 and negative 3, 5 and negative 3 for x and y. So 5 is the x, so where I see this x here, I'm going to put 5, and where I see y, I'm going to put negative 3. So we're going to do that. We're going to have negative 3. This is the x right here. That's 5. And then the negative 1/4 was our slope. And then what we're going to do is we're going to solve for b. So let's simplify this. This is negative 5/4 if we multiply these together. So then I'm going to add 5/4 to both sides to solve for b. So let's do a little fraction work. We need a common denominator. This one has a denominator of 1, so I'm going to multiply it by 4 over 4 to get the common denominator of 4. So that's negative 12/4. That's the same as negative 3, right? Plus 5/4, which gives me negative 7/4. So b is negative 7/4. So there I have the negative sign there. So then there we go. This is the equation of the line that is perpendicular and it goes through this point. So to graph this one, 7/4, negative 7/4. I don't usually like mixed fractions, but 4 goes into 7. Let's see, that's 1 and 3 left over. 1 3/4, negative 1 3/4, negative 1.75 basically. That is the y-intercept, which is not a nice y-intercept, but it's what it is, what it is. So we're going to find it. There's negative 1, here's negative 2. I'm going to go about right there. Okay. Now, the point here is another point that goes through it. I'm not going to try and use the slope to graph this. I'm not going to go down 1 over 4 because I already have a point. All I need to do is draw a line. See if I can do it. Okay. You know what I can do? Instead of trying to hand draw it, magical drawing. There we go. And then I'll just make it the color I want. There we go. So there's the line that is perpendicular that we found. All right, there's your examples. This page, I believe I said, goes into your notebook on 22. Yeah, pretty sure. All right, I'll see you guys next week.